So in chemistry, studied the mole concept, and last time I shared with you some of the things on mole concept, and I told you that we're going to be using my book for the examples and for the other explanations. So today we're going to proceed. We're going to look at the equation that is used when you have been given the mass, the molar mass, and the mole of a substance. So the equation, and this is on page 12, and I think I'm going to resend the book in the group. So the formula that you use when you have been given the mass, the molar mass, and the mole of the substance is, you say N is equal to M over capital letter M. So you need to know each and every letter here. So we can say where N is equal to number of moles. So this is number of moles, and we know that the moles are measured in MOL. Then where M is equal to the mass of a substance. So mass of the substance, and this is measured in grams. Then M, that's molar mass. And this is gram per mole. Molar mass is measured in gram per mole. So this is the equation that you use when you have been given the mass, the molar mass, and the mole of the substance. So you just say N is equals to small letter m divided by capital letter M, where small letter m is the number of moles, then where small letter n is the number of moles, where small letter m is the mass of the substance, and capital letter M, that's the molar mass. Let us look at the first example. In this example, I'm going to take it from my book, and the question from the example reads, how many moles are there in 0.35 gram of water? So how many moles are there in 0.35 gram of water? Let me just put another page here. Yeah, so the question says, how many moles are there in 0.35 gram of water? So the first thing that we're going to do is to collect the data. And from this data, we know that we have been given mass. So mass, we have been given as 0.35 grams. Then the molar mass, you need to calculate there, that's water. So water, that's H2O, and we know that the number of atoms of hydrogen there is 2. So 2 multiplied by the mass number of hydrogen is 1. So 2 multiplied by 1, that's 2. Then we also have oxygen. The number of atoms of oxygen there is 1 multiplied by the mass number of oxygen there is 16. 1 multiplied by 16, that's 16. So 2 plus 16, that's 18. So this means the molar mass of water, that's 18 gram per mole. Then we are told to calculate the number of moles. So we don't know the number of moles, so we're going to say N is we don't know, and that's question mark. So to find the number of moles, we're going to say N is equals to small letter m divided by capital letter M. N is equals to, here the mass have been given as 0.35 divided by the molar mass we have found, that's 18. So number of moles is equals to 0.35 divided by 18, that's 0.19 mole. So 0.19 mole. Let us look at the second example. So the second example reads, find the number of moles in 0.5 gram of an oxygen atom. So you need to note there, they have said oxygen atom, not oxygen gas. There are two different kind of things. So two, we have been told oxygen atom. So for the oxygen atom, this is just O. And for the oxygen gas, make sure you know this difference. If you don't know this difference, you'll be getting the answers wrong. For the oxygen gas is written as H2. So which means for the oxygen gas, the number of atoms here, there are 2. But for the oxygen atom, the number of atoms here is just 1. So we're going to collect our data. We're going to say data. And we have been given mass. Mass we have been given as 0.5 gram. Then the other thing that we have not been given is the molar mass. We need to calculate the molar mass. And since there is only one atom of oxygen, you just say 1 multiplied by 16, which is the mass number of oxygen, and that's 16 gram per mole. Then we are told to calculate the number of moles. That's question mark. So we're going to say N is equals to small letter m divided by capital letter M. Number of moles is equals to the mass, that's 0.5 divided by 16. So N is equal to, so 0.5 divided by 16, that's 0.031. So 0.031 gram per mole. Let us look at another example. Example 3. So example 3. For the example 3, it reads, what is the mass of 0.01 mole of hydrogen gas? So even here they have not said hydrogen atom. So hydrogen gas is H and the 2. So the first thing is to collect the data. So here the number of moles we have been given as 0.001 mole of hydrogen, of the hydrogen gas. Then to find the molar mass of hydrogen, which is H2, you say the number of atoms here is 2 multiplied by its mass number, that's 1. So this means it's 2 gram per mole. Then we are told to calculate the mass. The mass we don't know. So here we know that our formula is N is equals to mass divided by the molar mass. And to calculate the value of mass, you just cross multiply. So mass is equals to number of moles multiplied by the molar mass. So mass is equals to the number of moles have been given as 0.001 multiplied by the molar mass, that's 2. So the mass is equals to 0.001 multiplied by 2. The answer is 0.002. So 0.002 grams. Let us look at question 4. So question 4 reads, find the molar mass and name the element using the periodic table. Then A, there I have mass is 2 gram and the number of moles is 0.05 more. So here I'm trying to calculate the molar mass. So, and after calculating the molar mass, I'm going to identify the element using the periodic table. So the first thing here, I'm going to collect my data. So I'm told mass is 2 grams. So mass, that's 2 grams. Then the other thing is that the number of moles, that's 0.05 more. Then the molar mass, I don't know, so that's question mark. So you say number of moles equals to mass divided by molar mass. So over 1 here, you cross multiply, you're going to have number of moles multiplied by the molar mass is equals to mass. To calculate the value of molar mass, divide by n. Here you also divide by n. N and n will cancel. So molar mass is equal to mass divided by number of moles. So molar mass is equal to mass, I know that that's 2 divided by the number of moles, that's 0.05. So 2 divided by 0.05, that's 40 gram per mole. 40 gram per mole. So that's my my first answer. I have found the molar mass, but the other thing, the question that is asking me to do is to name the element. So using the molar mass that I've calculated, I'm going to go on the periodic table. And if I go on the periodic table, the element that has the mass number of 40, that's calcium. So this means my answer, if I identify the element, it will be calcium. And calcium is written in this way: capital letter C and the small letter A. Then you have a 40 here, which represents the mass number, and a 20. So the element, it's calcium. Then question B. Let me just put another page. Question B says, if the mass is 5.211 gram and the number of moles is 0.193 mole. So B, I've been told that mass, so I'm going to collect the data. So mass is equals to 5.211 gram. Then the number of mole is equal to 0.193 mole. I'm trying to calculate the molar mass. I don't know. So I'll say molar mass is equals to mass divided by number of moles. Molar mass is equals to mass, I'm having 5.211 divided by number of moles, that's 0.193. So here the molar mass is equals to 5.211 divided by 0.193, that's 27 gram per mole. So this is 27 gram per mole. So I've found the molar mass. The next thing, I need to identify the element. So if I go on the periodic table, the element that has the mass number of 27 is the element that I'm going to choose. And if I look at the periodic table, the element that has the mass number of 27, that's aluminium. So I can say element, it's aluminium. And aluminium is written in this way. There's a 27 here, there is a 13. Let us look at the other thing, which says calculating particles, which is on page 13. So we're going to proceed, and now we're going to look at on how you can calculate particles, and this is on page 13. So the formula that you use when calculating the number of particles, you say x is equal to number of moles multiplied by the Avogadro's number, which is Na. So this is the formula that you use when calculating number of particles. So x represents the number of particles, n represents the number of moles, and Na represents the Avogadro's number, or the Avogadro's constant. So I'll say where x represents the number of particles, so number of particles, and this can be atoms, ions, or molecules, and n, that's the number of moles, then Na, that's the Avogadro's number or constant. Avogadro's constant, and this is given as 6.02 times 10 to the power 23. So that's the formula that you need to know. This is just a simple formula, so you need to know this formula for you to calculate the number of particles. Let us look at the first example. So example 1, it says determine the number of particles in 2 mole of sodium chloride. So in 2 mole of sodium chloride, so the first thing is to collect the data. So the number of moles have been given as 2 mole. Then I know that the Avogadro's constant is 6.02 times 10 to the power 23. Then I'm trying to calculate x, which is the number of particle. So I'm going to say x is equals to number of moles multiplied by the Avogadro's constant. So my number of particle is equals to number of moles there, that's 2, multiplied by the Avogadro's constant, that's 6.02 times 10 to the power 23. So the number of particles, so if you multiply 2 multiplied by 6.02 times 10 to the power 23, you're going to have 1.204 times 10 to the power 24 particles. So this is 1.204 times 10 to the power 24 particles. So that's the answer. Let us look at the second example. So the second example, it says calculate 12.04 multiplied by 10 to the power 23 particles of hydrogen gas to mole. So I'm supposed to calculate the number of moles. So I'll say data. Here I know that the Avogadro's constant is 6.02 times 10 to the power 23. Then I have also been given the number of particle, which is 12.04 times 10 to the power 23. Then the number of moles, I'm trying to calculate the number of moles. So the general formula, I know that number of particles is equals to number of moles multiplied by the Avogadro's number. So to calculate the number of moles here, I would divide by the Avogadro's number here, and here the Avogadro's number. So this and this will cancel. So this means here I have n is equal to the number of particles divided by the Avogadro's number or constant. So I'm going to say number of moles is equals to my x here, the number of particles have been given 12.04 times 10 to the power 23. So this is 12.04 times 10 to the power 23. So this is over the Avogadro's number, that's 6.02 times 10 to the power 23. So if you do your calculations there, the number of moles is equals to 2 mole. Let us look at question 3. So question 3, it says how many particles of magnesium are contained in 2.4 gram of the substance. So the first thing is to collect the data. So here I'm trying to calculate the number of particles when I've been given the mass, and I've been given the mass of magnesium as 2.4 gram. Then what else? I also know that the molar mass of magnesium, that's 24 gram per mole. Then I'm trying to calculate the number of particles. I don't know. I also don't know the number of moles, but the Avogadro's number, I know that's 6.02 times 10 to the power 23. So the first thing that I'm going to do, since the formula that we use when calculating the number of particles requires the number of moles, so the first thing is to calculate the number of moles. So number of moles is equals to mass divided by the molar mass. So number of moles is equals to mass, that's 2.4 divided by the molar mass, that's 24. So number of mole is equal to 2.4 divided by 24, that's 0.1 mole. So 0.1 mole. Then I'll say x is equals to number of moles multiplied by the Avogadro's number. The number of moles here is 0.1 multiplied by 6.02 times 10 to the power 23. Then if you do your calculations there, x will be equal to 6.02 times 10 to the power 22 particles. So that's the answer. Make sure you do question 4. Make sure you go through question 4.